And we might have also worked on several types of widgets. I believe we worked already on a paragraph widget, on a heading widget. This assignment will let us focus on two additional types of widgets: the list widget and the image widget. Okay. We will implement also the one-to-many relationship between topics and widgets. So to implement this, you'll need to create a Java class that models topics inside of a class called topic.java that has the following fields. Notice that the primary key that we're going to use to uniquely identify these records or these instances is going to be an integer. Right? Also notice that the name is ID and not underscore ID, how we might have called it previously. Right? Another thing is that is going to have a field that allows us to capture all the widgets that pertain or belong to this particular topic. Right? And the way typically we implement or how we model one-to-many relationship in Java is that the parent typically has a collection or an array or a set or a map, right, of the child, right, of the children. So this is exactly how we would model it using a Java class. Right? Also notice that because topics belong to lessons, the way we're gonna model that is the lesson's gonna have a string for the unique identifier of the parent lesson. Very much like you might have done for modeling that widgets, right? You keep track of the topic ID, of the parent topic ID, yes, to be able to filter which widgets belong to which topic. Same thing here, right? We're gonna use the lesson ID to know which topics belong to which parent lesson. Make sense? Okay. Also, we're going to be using a widget class, which you might have already worked on in previous assignments. A couple of changes from previous implementations is that the ID previously might have been implemented as a string. Here we're going to change it to be integers. Okay? Because they're going to be stored in a relational database, the primary key is going to be an integer that's going to increment, as we insert more and more records. It's going to auto increment. So we're going to change that to an integer. Also, if notice that the way we're going to implement the one-to-many relationship between the parent and the children, notice that this widget is a child of some topic, belongs to some topic. So the way we're going to model that is that the widget is going to have a reference to its parent topic. See that? This is in contrast how we might have done earlier, where we had a string that represented the topic ID, right? That we're capturing only the primary key or the foreign key, right? That told us which topic do we belong to, right? So this is going to be a little bit higher level. So instead of maintaining the identifier of the parent, is going to have actually a reference to the parent, all right? So it's a little bit higher level. Everything else stays the same. Also notice that we're going to annotate. We're going to use these JPA specific annotations, one-to-many and many-to-one, which specify that these two, the topics and the widgets, are in a one-to-many relationship and how the relationship should be resolved. Right? This one is saying that these widgets that we are encoding in Java as a collection should be encoded using primary keys and foreign keys in the relational database. And we'll see how that all works. Right, this is what creates that relationship in the relational database. Right, so this annotations is what allows us to map this high-level object-oriented code to a low-level representation in a relational database. Also, to be able to send these widgets to be stored in a relational database and to retrieve them and to update them, to delete them, these records that live in a relational database, to do that from Java, we're going to be using what are called repositories. Repositories are going to be Java objects, right, that are going to provide a standard API that will allow us to manipulate these records in the database. Right? They're going to provide some generic functions such as save or delete by ID or find by ID or find all. We'll provide some boilerplate implementation that allows you to interact with the relational database. Right? So we'll create one for the topic and we'll create one for the widget. Okay? Now, some of the functions, you might need to create some custom functions to interact with the database. Right? There's some boilerplate functions that are already implemented out of the box, but here we're asking you to implement a couple of custom functions, right? And we'll see how to do that. Finally, once you have the data layer, this is the data layer, right? We have the relational database, we have the data model, we have the repositories. We're going to use a service, right, which is going to encapsulate all the CRUD operation at a higher level. Right now, the repositories are implemented at low-level generic functions. Right, we're going to wrap those low-level generic functions into a higher-level API, which will allow us to create, topics, find topics for lessons and whatnot. Okay, so this allows you to create a topic for a lesson ID. This allows you to find all the topics for lessons, very much like the widgets that you implemented last week, but instead of being stored in arrays, right, we're going to abandon arrays, right? So we're not going to store it in the memory of a server. Instead, these are going to be backed by records and tables in a relational database. So that's for topics. For widgets, similarly, pretty much the same thing. We're going to create widgets for a given topic ID. Notice that the topic ID is an integer, not a string. Also, we can retrieve all the widgets for a given topic. Again, the topic ID is an integer, not a string. Also, find all widgets, find widget by ID. Now, some of these functions, find all widgets, find widget by ID, you probably won't need them, right? Nevertheless, implement them. Right? It's up to you if you need them, but just to practice, right? Implement them nevertheless. If you need them, sure, use them. Also, if you need additional functions, please, feel free to declare your own. Right? So I didn't make them optional, so you have to implement it, even though you might not need them. And I forgot to remove optional here. So you probably won't need these, but if you do, certainly feel free. Once you have those services, you'll create controllers to expose this behavior in a web API, right, to a URL for creating topics for a given lesson, right? You have the parent lesson, the lesson ID, and then the topic. Now, these URLs used to go to a remote server that was implementing a generic API for you, yes? But now you're going to implement that API yourself, right? Very much like you're doing for this week for the widgets, you're going to do it for the topics. Okay, right. So creating new topics, getting the topics for a lesson, changing a particular topic, deleting a topic, finding all topics. You probably won't need this. It's very unusual that you'll ask for all the topics, right? Nevertheless, implement it. Also, the same thing for widgets. You might have already implemented widget control, or most of it already. You're probably finishing that up right now as we speak, we're asking you to make just a few tweaks for the next assignment. Instead of the topic IDs being strings, these will be integers instead. Same thing for find widgets for topic. Instead of being strings, these will be modified to be integers. Right? And I think that's the bulk of the modifications. Obviously, you'll need to create the necessary JavaScript clients that interact with this from React, and then implement the widgets to use these new APIs. We'll implement two widgets. The list widget. The list widget allows you to create a list, right? Either an unordered list or a ordered list. You see the preview down here. And each item in the list is just an individual line in a text area, right? So you'll use probably new line to know that each item is separate, right, as a separator. And for image widget, you're going to keep track of just a URL of some image that lives on the network, right? You're not going to store the binary or the blob image in the database. Instead, you're just going to keep track of the URL. Whatever that URL maps to, presumably an image, right, will be used to render it down below as a preview. Okay? Please keep it clean.
What's the API endpoint you're using?
For what? I won't start the image widget.